Thank you for joining us today, and in this video we are going to practice using the inverse function theorem on inverse derivative. So we've now learned the procedures. We need our formula, we need to simplify, we need to do this, we need to do that. But the most important thing from the steps is the formula. When we're able to write down the formula, all the steps are in the formula, right? So it will help us to get to where we want to get to. So let's jump right in. So we want to use the inverse function theorem to find the derivative of the following function. So this is the first function. Let's go through quick. So the first thing that we need to do is we need to use the formula, right? We need to write down the formula. So f inverse prime of x is equal to 1 divided by f prime f inverse of x. So that is what we need to write down. So this is the first step that we need to do. Now, when you write this one, the rest is looking at what is at the denominator, then you try to find all of them. So we need f prime, we need f inverse of what? X. So now let's go through by finding f inverse of what? F. So let's go through, we know how to do it. So y is equal to, first let y to be equal to that. So x squared plus 5. Then y will be equal to, so we need to interchange x and y. So y squared plus 5. Then we've done a couple examples on this one. So here we need to pick the lane. So if this is your first time, you can go back to learn more on how to find inverse of the function 5, right? So now this is going to be x is equal to y squared plus 5 in parentheses lane e. So lane e is going to give us 1. So we are going to have this to be equal to y squared plus 5 all times 1, right? So ln of x is equal to y squared plus 5. So this is what we are going to have. Then we need to make y the subject. This is going to be so complicated. All right, so let's get to it. We subtract 5 here, we subtract 5 here, or we move the 5. So ln x minus 5 is equal to y squared. And we need to pick square root on both sides to make y the subject. So y will be equal to square root of ln of x minus 5. So this is the f inverse of x, right? So ln x minus 5. So this is the f inverse. Good. So since now we've gotten our f inverse, we need just the f inverse. So I'll clean up the solution. Good. Then I'll just move this guy. Here, let me just put it here. Good. Then we need f prime. So let's try and find f prime. So f of x is equal to e to the power s squared plus 5. Now, how to differentiate an exponential function? I have video coming on how to do derivative, exponential function, and other functions. So when it's out, try to make sure you go through the videos. So for exponential function, I'll maintain the function when I want to differentiate times. I'll find the derivative of the exponent. So this is going to be times ln of the base, but ln of the base, which is e, is 1. So we are going to have this plus this times 2x, and this will be 2x e to the power x squared plus 5. So this will be the derivative of the function. So since we've gotten the derivative of the function, the next thing that we need to do is we need to make sure, so this is the derivative f prime of x. We need to make sure we plug in f inverse into what? F prime. So we need to have this one. Now we are going to look for this. So f prime of f inverse of x, f inverse of x is equal to, now f prime, what is f inverse? F inverse is root of ln x minus 5. Good. So we are going to plug this or substitute this inside all the x functions. So as we said, it's better for us to make sure we have all the functions in parentheses because our x here is in parentheses. So we need to make sure 2x e to the power x squared plus 5. So we can see that x is here, x is here, x is here. So if we want to use, this is f prime and this is also f prime. So if we want to use the function here, then we can see that we want to use the function here for this. But we can see that this is x in the parentheses here. That's the reason why we have the x in the parentheses here, x in the parentheses here. So if we are using the same function here, then all we need to do is we need to change all those in the parentheses here to the one here. So we are going to have, let me shift this one here. So we are going to have 2 times the one in the parentheses, which is root of ln x minus 5, then e to the power root of ln x minus 5 all squared plus 5. So this is what you are going to have. Then when we simplify, we are going to have 2 root of ln x minus 5 e to the power. So now this will cancel this. So we are going to have ln x minus 5 plus 5, and this is going to give us ln x minus 5 e to the power. Then this guy too will cancel this guy here. So things are getting amazing. Then we have this. And guess what is going to happen again? This is 2 root of ln x minus 5. And this right here is x. So times x. How did I see that it's x? Now I can bring down the x times e to the power ln x, ln, and this is 1. So if this is 1, give us x from the top there. Good. So when I simplify, I'm going to have 2x root of ln x minus 5. So now we can see that the 1 at the denominator here, which is this, is equal to this. So we are come to just plug this right here. So our final solution will be 1 divided by 2x ln x minus 5. So this will be the final results. So as I said, the strategy, you can try to, oh, which one was the inverse? Okay, good. So you can try to differentiate this function right here, and you see that this is the result that you are going to get. When you try to differentiate this function, this is the results that you are going to get here. Okay, so now let's move to the next one. So now we are done with this. Now let's look at the b. Let's look at the b. So the same thing again, we need to write down the formula, right? So f inverse prime of x is equal to 1 divided by f prime f inverse of x. So you see that the more you practice, the more you are solving example with the formula, it is going to automatically stick. Like you will remember it anytime you are going to use it, anytime that you need it, right? Anytime you see a question and the question is asking you to using the inverse derivative, you don't even need to think about it for a long time and it just comes out and then you can use it. So now still the same process. So you see that you become very familiar with the process too as well. So we need to find f inverse. So let y to be equal to 1 divided by root of 2 plus root x, and then we make y the subject. So interchange x and y. X is equal to 1 divided by root of 2 plus root of y. This is going to be interesting. Then x root of 2 plus root y is equal to 1. Then what I'm going to do is, since I want to make y the subject, I'll square both sides. So square 2 plus root y, which is supposed to be equal to 1 squared. So when I want to square something, like if I have ab squared, this is the same as a squared times b squared, right? When you want to square two functions and you're multiplying, so that's how it's supposed to be. So this is going to give us x squared times root of 2 plus root of y squared, which is equal to 1. So this will be x squared, and now this will cancel this. So we are going to have 2 plus root of y is equal to 1. Now we want to make y the subject, right? So what we need to do is we need to first divide through by x squared here, x squared here. So we can have 2 plus root of y to be equal to 1 over x squared. Then we need to make y the subject, minus 2 minus 2. So root of y is equal to 1 divided by x squared minus 2. Then for us to get the y again, we need to square this and square this one too as well. So we are going to have root of y squared to be equal to 1 over x squared minus 2 squared. Good. So y will be equal to, this one will cancel this. So here we can try to simplify the 1 in the bracket. So finding LCM, x squared goes here 1. 1 times 1 is 1. This is like divided by 1, right? So 1 goes to x squared, x squared times this will give us negative 2x squared all squared. So this is what you're going to have. So this is the inverse, right? Good. This is going to give us the inverse of x. So now this is what you are going to have, the inverse. 2x squared divided by x squared all squared. So this is the inverse. So let me pick this one. We need the inverse. So let me pick this one and put it here, and then clean up the rest of the solution. So very simple, getting along with. Then the next thing is we need f prime. F prime. 1 divided by root of 2 plus root x. So one of my videos on derivatives that is coming up, you will see that I will show you how to make your life simple whenever you are dealing with derivative. So this is how I'm going to make my life simple. 1 divided by, the root can be written as 2 plus, so root, if you have root, I can write it as to the power half, to the power half. So this big whole root is affecting everything, so to the power half. And this one is affecting the x, so to the power half, the same thing here. Then if I don't want to use the quotient rule, so here we can use the quotient rule, or I can just make sure I use the power rule from here. It's also the same thing. Any of them works. So I can use the quotient rule, or I can use this. So if I want to use the power rule, what I need to do is I'll move this guy here up. And when I'm moving it, since this is positive, it tends to negative. So I'm going to have 2 plus x, 1 divided by 2 to the power negative 1 over 2. Then I take the derivative from there, right? Which is going to be using the power rule. But I just want to use the quotient rule from here. So here I'm going to have u divided by vn. So u is 1 and vn is 2 plus x 1 over 2, 1 over 2. So what is u prime? U prime is going to be 0 because a derivative of a constant is 0. So now what is vn prime? Vn prime, we need to use the power rule, composite rule. So it's two things together. We call it change rule, right? So when I take my video, when I'm doing the video on derivative, you understand all this stuff here. So power rule, this guy drops, we subtract 1. So we are going to have 1 over 2. Then we maintain the 1 in the parentheses. we subtract 1 and we get -1/2 times, then we differentiate what is inside the parentheses. So when I differentiate this, I'm going to get 0. And when I differentiate this, I'm going to have, I'm using the power rule for the x to the power 1/2 too as well. So I'm going to have 1/2 down, x to the power -1/2. Then maybe I can think of doing some small simplification. So this is the same as 1 divided by 2 times. So since this is negative, I can write this one as 1 divided by x plus x 1/2 to the power 1/2. And then since this one too is negative, I can write it also the same thing. So times 1/2 times 1/x to the power 1/2. Is that right? Good. So let's continue simplifying. Half times half is not 1, it's 1/4. Then I can multiply this and that. So this and that is going to give us times 1 divided by, x to the power half times 2 plus x to the power half all to the power half. So this is what you're going to have. So this is just the u prime. This is just the u prime. So what will be the f prime itself? So f prime, as we know, is then u prime minus u vn prime divided by vn squared. So let's do the substitution. What was vn? Vn is 2 plus x 1/2, 1/2 times what is u prime? U prime is 0, so this one will go to 0. Let me push this one here small, or let me even clean this one because this is too long, and shift this one here small. Minus, what is u? U is 1, and what is vn prime? So vn prime is right here, everything here. So we are going to have, let me put them together so I can multiply this to this so that it becomes very simple. So this one is going to be 1 divided by 4, right? Now I want to do something here. This guys here, right? If I have a to the power m times b to the power m, you see that they are having, the a is having the power of m. This is also power of m. So this one can be written as ab to the power m, right? So look at this. This here is to the power half. This here too is to the power half. So I can combine this all to the power half. So I'm going to have something like this. X times 2 plus x to the power half all to the power half. So here, that's how we are going to get. Divided by, what is vn? Divided by the vn squared. So 2 plus x to the power 1/2 all to the power 1/2 all squared. Let's look at how we can simplify this. My page is almost full. So what I can do is I can clean some of the solution up, right? So let me try and clean this up here, up here, since we've done it already, and shift this guy top here. So I'm moving it here, right? So I'm going to have, now this time this will be 0, and then this time this will be just the negative of this, and then this 2 will cancel this, so it will be left with just the one in the parentheses here. So we are going to have -1 divided by 4. Now we can write this half as a root, so we can have it to be root of x plus. Now don't forget, this is also can be written as, this can also be written as root. So I'm going to write, this one's supposed to be 2 root of x. Good. So this is what you are going to have on the top. Then divided by. So for the divided by, I'll do it this way, divided by. Now, as I said, this will cancel this. So it will be left with this. So divided by 2 plus, this guy here can be written as root x. Right. So since we've gone through this process, let me clean this and clean this one too. Good. So that we can now focus on this one. So now I have, let me copy this and paste. Oops, didn't copy. Let me copy this and paste. Copy, paste. Good. So I have this one. I write everything back. Times. So the division will change to multiplication, and this one will be 1 divided by 2 plus root of x. So this is what you are going to have at the end of the day. So when I combine this, this is going to be negative 1 divided by 4 root of x, 2 plus root of x times. So good. Let me even combine it together. So when I want to multiply, when I bring this one will be 2 plus root 2 root x. Then I have times root of x, 2 plus root x. Good. So this is the f prime of x. So you can see how complicated this one is, but we can do it. So now let's look at the next step. The next step is for us to plug in f inverse into f prime. Yes, right here. So we want to plug this one inside this. So let me shift this one on the top here, small somewhere here, and let's look for f prime of f inverse of x. So f prime, what is f inverse? So f inverse, we had this, so we are going to put it inside here, 1 minus 2x squared divided by x squared all squared. Good. So now we are going to plug this inside f prime. So all the x into parentheses, all the x into parentheses, we put all of them in. So we are going to have negative 1 divided by 4. Then we are going to have 2 plus root of. So now the root, since this is x, now the x is the whole of this. I'm going to put this one here, everything in the bracket here. So let me copy this so that I can just write them and put it there. So paste and minimize it inside this one. Good. So this is what I'm going to have. Or let me write it. I'm being lazy. Let me write it. So this is going to be this. So I'm going to paste this one there. So I'm going to have 1 minus 2x squared divided by x squared all squared. So that is the first one here. Then I come here, I come and do substitution. So that one will be root of, I have first x here and x is this one. So I'm going to have 1 minus 2x squared all divided by x squared all squared. Then open bracket 2 plus another root of this one again. So I can copy this one. I'm not being lazy. I'm making use of the tools. So I'll paste it there. Let me minimize it small. Good. So now I have this one here. Now let's see what happens. We can do some cancellation here. This guy will cancel this guy here, right? But you see, we cannot cancel this guy and this guy because they are multiplying. So for us to cancel this guy and this guy, we need to use the idea of root of AB can be written as root of A times root of what? B. So that now we can separate this one and then we do the cancellation. Now since we don't need f prime and this one, since we've used them already, let me try and take them out. This guy said he won't go. Okay, if he won't go, be there. So like let's move this one up small. So now we are going to have this one up here. Now let's go. This is going to be -1 all divided by 4, 2 plus. So this one will be left with 1 minus 2x squared divided by x squared. And then, as I said, we can split this one into 2. So this one is going to be root of 1 minus 2x squared divided by x squared all squared times root of the one in the parentheses here, 2 plus root of. So I think we can also cancel this guy and this guy. Good. So it will be left with plus 1 minus 2x squared divided by x squared. Now let's try and do some simplification and see if we can simplify it. So we are done with this one. Since my board is finished, I'll clean up the top one and then I'll shift this one up. So let's move this one up again. Good. So the next step will be -1 divided by. So in this bracket, the LCM is 4x squared. So now this is divided by 1. 1 goes here, x squared. So when I multiply it, I get 2x squared plus 1 minus 2x squared. Because here is x squared goes here 1. 1 times this will give us the whole of this. Good. Now that we've separated this one can cancel this one here. So we are going to have times 1 minus 2x squared divided by x squared times, then the simplification that we did here is the same thing here, right? So this is going to be root of everything that we are getting here, 2x squared minus 1, no, plus 1 minus 2x squared divided by x squared, right? Now this guy will cancel this guy too will cancel this guy here, right? So it means that if I want to clean this guy here and move this one up, we are going to have -1 divided by 4 times, this one will be left with 1 over x squared. This one will be left with 1 minus x squared divided by x squared, and this one will be left with 1 divided by root x squared. Wow. Now what can we do? Can we do something? Yes, we can do more things. So let's try and simplify. So this video is keeping long. So the next example I'll give you to try. So what we are going to do from here is we are going to simplify. So this one here is like having 1 over a squared root. This is the same as root 1 divided by root of a squared. This one will cancel this, and root 1 is 1, which is over a. So this one here is 1 over x. Can we simplify anything again further? No. So we are going to have -1 divided by, when I multiply this, I'll have 4 over x squared times 1 minus 2x squared divided by x squared times 1 over x. So this is -1 divided by, when I multiply this, I'm going to have 4 1 minus x squared 2x squared divided by, when I multiply this and that, I'm going to have x to the power 5, right? And our final simplification from this is going to be from this is going to be this. So this is going to be -1 divided by 4 1 minus 2x squared divided by x to the power 5. And when we change this one to multiplication, we are going to have x to the power 5 for 1 minus 2x squared, and this is going to give us minus x to the power 5 divided by 4 1 minus 2x squared. So this will be this. This will be this, the one at the denominator, right? So now the one at the denominator is this. Let me pick it up there. Let me pick it up here. So let me just clean everything here. Clean everything here and bring this guy here. So we can see that this is what is here. So we just need to plug it in here. So we are going to have this to be equal to 1 divided by, so I'm come to do it divided by like this. So 1 divided by this, then I'll write this one here. So I'll have minus x to the power 5 divided by 4 2 minus 2x squared, right? This is not part. This is not part. So don't look at it. Okay. So this is going to be 1 times -4 2 minus 2x squared divided by 5x. And this is going to give us -4 2 minus 2x squared divided by x to the power 5. This was a long journey. This was very long, right? So this is the final results for f inverse derivative. So the last video, so we are done with this and that. The last question, which is this one, try and see what you are going to get. See you in the next video.